Hello, welcome back. We are going to move forward now into investigation 6. What we left off with was the definition of a period for a trigonometric function. And that's just the amount, the interval of input required for a complete revolution of the circle. In the context of what we're going to be looking at, we're going to be thinking of theta and time being interchangeable. So we can think of it as the period, how we ordinarily think about period in terms of time. So it's how many seconds or how many minutes or hours, whatever the circumstances are for us for an object to complete a 2 pi radian to complete 2 pi radians of a full revolution of a circle, and that's 2 pi radians, or 6.28. So in this question, we have a Ferris wheel. Maybe we can draw it. And it tells us that it has a radius of 52 feet. A radius of 52 feet, and this horizontal diameter is this distance is 58. And that the radius of the Ferris wheel is 52 feet. So it goes on to say, if the Ferris wheel rotates at a constant rate of not 1 radian measure per second, or per minute rather, but 1/4 of a radian per minute. So that would be 4 times as slow as would typically be the case if we were traveling at 1 radian per unit time. So if for theta and t being 1 radian per 1 unit time, takes 2 pi seconds. Well then, if theta equals 1/4 t, then it's going to take 4 times as long. So that would take 8 pi seconds, which is roughly about 25.13 minutes. All right, so part B, a function g, and we want it to be a function of time. We need a function that represents the distance in feet of the wheel bucket above the ground now, not above this horizontal diameter, but above the ground, as a function of time since the Ferris wheel began rotating from this 3 o'clock position, and assuming it rotates at a constant rate of 1/4 radian per second. So if we had a radius of 1, then our model, if we had a radius of 1 and the horizontal diameter of the Ferris wheel were on the ground, if that were even possible, well, I'm sure maybe there is a Ferris wheel that goes below the ground, but if we just had that, we would be looking at sine of 1/4 t, right? But we need to adapt that to a radius length of 52, so we multiply that by 52. And now we think our minimum value is going to be at 6 feet above the ground, right? This distance, 58, minus 52 would give us that our minimum value would be 6 feet. So we know the value of this function is always going to be positive, but we need to account for our horizontal diameter not being here. It's not here, which is what this would model. It's always going to be 58 feet higher. So we take all the outputs of this function and we add 58 feet, and this will model this Ferris wheel with this Ferris wheel that is that has a horizontal center that's 58 feet above the ground. Okay, so now they want you to get a sense for if we have this same Ferris wheel that's 58 feet above the ground with a radius of 52, what happens if we change the speed that the Ferris wheel spins to 3 radians per minute? So, well, obviously it's going to be 3 times as fast. Again, for 1 radian per second, every 1 theta radians would correspond to 1 unit time t, and so 1 full revolution would be 2 pi seconds. So now, if we triple that, instead of a complete revolution of the circle corresponding to 2 pi seconds, now in a third of that amount of time, we are going to have completed a full revolution. So 1/3 of 2 pi seconds is equivalent to 2 pi over 3 seconds per revolution. And that is, and this would be our period for the function, 2 pi over 3 seconds. So if part D asks if h of t was sine 2t, and we wanted to know what that represented, 2t means that instead of traveling 1 radian per unit time, we're going to travel twice as fast. So our 2t tells us that that the wheel spins twice as fast, and this means that that will correspond to a period. It will take not 2 pi seconds, but pi seconds for 1 revolution. Okay, so I'm going to end this one here. When we come back, I'll pick up with number 4 in investigation 6. See you in the next video.